ఆ మంది సీన్ పెడితే ఏమైంది? మనుషులు లేరు. Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. For you today, we are going to discuss about solutions, part 2, multiple choice questions, along with bit concepts as well. Sarkar Hars, how are you? Good afternoon. In this NEET 2025 1000 most expected question series in the last 45 days, we are discussing this series of 45 days, almost 10 days over. We completed atomic structure, classification of elements, chemical bonding, thermodynamics and equilibrium, and a part of general organic chemistry. All multiple choice questions has been discussed along with the concepts as well. And in this today's session, yesterday we started with solutions where we focused more on concentration terms and we did very good number of questions, and today we are going to talk about solubility, Henry's law, Raoult's law, and a part of colligative properties. Ready for that, children? So get ready for the sessions, and every day my session is at 1:30 p.m. and get ready with a pen and paper and start solving along with me. If you give the correct answer and if you give the wrong answer, doesn't matter, you give the answer, so that we'll understand where you are doing wrong and you'll be learning concept as well. So coming to the word of the day, crack your NEET examination. So for this NEET examination, just everybody is aiming to crack it. So that is itself is a worth of the day, and for that attend the classes without any fail. If you fail to attend the class, watch the recording as well. So please like and share and subscribe that Infinity Learn YouTube channel. And in the Google App Store, you are going to see Infinity Learn app, and you download that app and you can experience all kinds of live classes, mock test, and create your own test and 24/7 doubt resolutions. Okay, bacho, can you all able to hear me? Can you see me? Please confirm in the chat box. So what about the regular students? Give me response in the chat box so that we can have an interactive session. So, and whenever you are preparing for anything, any examination, it is required how you are studying and where exactly you stand. For that, scientifically designed Infinity Learn is scientifically designed AITS NEET 2025 All India Test Series Pack. In this AITS, you are going to have 24 AITS examination, 27 AITS examination in the 13 unit test, 4 part test and grand test. It is based on NEET examination, and 20 online NEET mock test, and 25 NEET topic wise previous year questions, and 3 physics, chemistry, biology books along with video solutions on the app, and detailed solutions and performance reports for every test. And last but not least, your performance is benchmarked with Sri Chaitanya students. अरे इतना सारा facilities India online education platform में सिर्फ Infinity Learn दे रहे हैं. It was around 5,999 था. When you have the special discount because आगे exam है, so Infinity Learn want to do better for the students. So when you apply YouTube 50 off coupon code, you are going to get it for half of the price. It is 2,999. So promotion is over. So everybody, in the description box, link is available. You just click it and you enjoy seamless preparation for the NEET examination. Okay, bacho. Anyways, we'll start. Yes, students are requesting us little concept we have to explain. Then we go with the multiple choice questions, right? Is that fine, or you want me to directly go into the MCQ? It all depends on you. It requires a bit of interaction between you and me. Coming to yesterday, we completed concentration terms. In the total solutions and colligative properties, you have concentration terms, you have solubility, you have Henry's law, Raoult's law, and vapor pressure and Raoult's law, and colligative properties, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure, and abnormal molecular mass as a Van 't Hoff factor. These many topics are there. You are going to get a question from the vapor pressure and colligative properties and Van 't Hoff factor. These are the three major areas where you are going to get it, and from there you are going to get vapor pressure concept into the today's class. So be interactive. It is not a radio telecast session, so that if you are interactive, we can do the best. Fine. But so you can see solubility. Solubility of a solute in a given solvent represents the maximum. Sunita Kadam, hi. Maximum amount of solute that can be present in a liter of solution. That can be in gram per liter or mole per liter. And solubility of solid in a liquid. Let us say sodium chloride is dissolved in the water. So it is soluble. How it is soluble? It is based on various criteria that you have to connect with thermodynamics, that you have to connect with chemical bonding, that you can connect with the solubility from the solution. So these three are interlinked here. Okay, so especially for the NEET examination, the concept that you are learning should be checked your understanding levels as well. So don't expect a toughest paper and a lengthy numerical. Rather, you are going to expect the question paper intended to test your understanding level. Mind it, that is the fundamental aspect you need to know. Okay, so let's go ahead with when the solute is continuously added to the constant shaking and stirring, some solute particles and solution is collide with the solid solute particles and get separated out, right? And this process is known as crystallization. So solution is said to be saturated in that situation. And you can say a stage reached when the two processes, resolution, crystallization, are in the equilibrium, then it is said to be a saturated solution. Okay, this is itself is a class 12 chapter beta. Who is at PCB Galaxy? Okay, now let's go ahead. The solute plus solvent gives rise to solution. Solution is a homogeneous mixture, and in that the solution at this stage is said to be saturated because there is an equilibrium. Mind it. If somebody says it is saturated solution, there should be an equilibrium between the dissolved and undissolved entity. And unsaturated solution, some more solute can be dissolved, and supersaturated solution, and it is having the more ionic product in it. Okay, anyways, the solubility of a solid in liquid at any temperature is defined as the maximum amount of the solid, that is your solute dissolved in 100 grams of the liquid. So the definition itself, the definition part itself gives you a characteristic questions. Okay, now moving ahead, molar concentration is given as a molar solubility. Okay, Suchibrata, good afternoon Suchibrata, good name. Okay, so it is given as a mole per liter. Generally we talk about the molar solubility, that factors, that is very important beta, factors affecting the solubility of solid in liquid, that heading is important. Okay, so Suchibrata, you can see the factors, nature of the solute as well as a solvent and the temperature and the pressure. Three things are important, and pressure has no effect at all, and temperature has effect, and nature of solute and solvent we will discuss about it. Now you can see here the three things we elaborated here more. So nature of the solute and the solvent, dear children, nature of the solute and solvent. You can see in general, solid dissolves in liquid which is chemically similar to this. So like dissolves like ionic solids dissolves in polar solvent like water. Covalent solids do not dissolve at all. Covalent compounds may be dissolved in non-aqueous solutions, that's a different matter. Okay, you can see here the solubility of the various liquids, various solids as the temperature. Temperature does matter. Generally, as temperature increases, solubility increases. You can see that is observation. Don't by heart the graph. Observe that. NaNO3 is more soluble than calcium chloride, lead nitrate. So the least solubility KClO3, chromates, dichromates. But one thing I can say, NaCl you can see its solubility is not changing with temperature. Mostly you can see. Thank you very much, Suchibrata. Thank you very much for your compliment. And there you are going to get an expected questions from the NEET examination. Mind it. That's the reason why I want you to discuss the multiple choice questions as well as the concepts here. So let's see why so. So the temperature, the effect of temperature of the solubility in general, the solubility is an endothermic process. In that process, you can see very important, heat of a solution is equal to sum of the lattice energy and hydration energy. So the lattice energy is endothermic process, hydration energy is exothermic process. But for the sodium chloride, especially for the sodium chloride, this lattice energy and hydration energy, these two are going to be the same. That's the reason why when sodium chloride is dissolved in the water, when you increase the temperature, decrease the temperature, kuch farak nahi padta. Okay, you can see this is a super awesome. You are going to get assertion and reason type questions from the NEET examination. That's very important. Okay, for NaCl lattice energy is 184 kilocalories. You don't have to memorize this value. And hydrogen energy is 182.8 kilocalories. And hence the solubility, dono barabar hai. So solubility does not vary much with temperature. That's very important. That's very important. Okay. So moving ahead, pressure. Pressure has a very little effect or no effect. You can claim this is no effect on solubility of the solid and liquid, because solids and liquids are highly incompressible. And also solubility of a gas and liquid, you have to talk about Henry's law. So we'll discuss about this Henry's law here. Suchibratam, if you have any doubts, please let us know. So I will be very happy to explain your doubt. Shankar Harsh and Sunita Kadam, and you can see here nature of the gas. It depends upon various factors like nature of the gas and the solvent. More polar gases are more soluble in the liquid, and the gases with more intermolecular forces can be easily soluble, and the gases with lower critical temperature will have the more intermolecular forces, can be easily soluble, and various points we need to know here, okay, in this effect of temperature. So gas solvent gives rise to solution, and this is exothermic process. Delta H is equal to negative. As a result of this, temperature increases, solubility decreases. Le Chatelier's principle के हिसाब से solubility decreases. Got it? Fine. Now, one more important effect of pressure, that is given by Henry's law. At a given temperature, as the pressure of the gas on the surface of the liquid increases, solubility of the gas increases. Okay, so when you see this is a liquid carbonated water and carbon dioxide is pressurized, so that it is going to be increased. Solubility of the gas, mass of the gas that is dissolved is directly proportional to the pressure over it. Okay, so that is given as when the piston is pumped down, so the pressure is increased, so less gas molecules are soluble here, more gas molecule are soluble if the pressure is increased. This is the diagrammatic representation of Henry's law. Everybody, any doubt? So Henry's law, that is given in various ways. And pressure of the gas, mole fraction of the gas is directly proportional to the pressure of the gas. You can say pressure of the gas, you use this formula, pressure of the gas is equal to kH and mole fraction of the gas, that is. So you have to take mole fraction of the gas in the solution, right? Now kH is a constant. For a gas, the kH value changes with the temperature, and as a gas and another gas, if these gases solubility at a given temperature is concluded based on the values of the kH, the gas with lower kH value is going to be more soluble. That's very important. So I would say solubility inversely proportional to Henry's law constant. Got it? That's very important. And Henry's law constant, it is actually said to be constant. How it is constant, even I don't have an actually I wonder why it is constant. It is not constant. Actually this value changes gas to gas, and it is a constant, and it is changes for a gas as the temperature changes. So it's a constant for a gas at a given temperature. That is true. It's very, very important. Okay. Now let's talk about the most commonly used Henry's law may be defined as the partial pressure of gas is directly proportional to the mole fraction of the gas in the solution. अरे बेटा, this definitions ना अलग अलग तरीका NEET examination में पूछा जाएगा. So that you need to have a tremendous command on the definitions as far as physical chemistry part is concerned. I am pretty sure about that. Okay. And you can say partial pressure of the gas is equal to Henry's law constant and the mole fraction of the gas. I would say partial pressure of the gas is directly proportional to mole fraction of the gas. So that mole fraction and partial pressure is taken, you are going to get a straight line with a slope. Henry's law constant is given. Mind it, studying the graph is very important. Take a note of it, everybody. Take a note of it. Slope of the graph is Henry's law constant. Ready to do the numericals, bachcho? Yes, you are ready. Yes, any doubts? So let's go ahead with further things. Different gases will have different kH values, I already mentioned. Henry's law constant kH is a function of the nature of the gas. Which of the following is true with respect to Henry's law constant? This could be a statement. And studying theory in physical chemistry is so tricky. Focus on the theory, rather problematic and big numericals, mind it. Maximum you are going to get 5 numericals. I am feeling less than 10 numericals in the entire paper. Rest of the things, your understanding abilities, your application abilities will be tested. No doubt about that. Fine. So with an experience, with the feedback from the infinity lane I am giving you, for 2025 examination for the NEET, you follow the same fundamental. And the second point, greater the value of kH, lower is the solubility of the gas at the same temperature, same pressure, and according to the equation, the particular temperature. जब तक temperature constant है, तब तक kH value constant है, एक given gas के लिए, है ना? And last point, the value of kH value increases with increase in the temperature, implying that the solubility decreases with increase in the temperature of the same pressure. Okay. So as I mentioned, solubility इसका KH वैल्यू का इनवर्सली रिलेटेड है. जो भाई छोटा छोटा ट्रिक्स है मेरे क्लास में, आप आदत पकड़ना. एंड एवरीबॉडी टेक ए पेन एंड पेपर, राइट द यूजफुल पॉइंट्स दैट यू फील इट Suchiprata, right. Okay, sorry. Next, it is going to be limitations of Henry's law. Very good. Here Henry's law is applicable only for the gas. The pressure shouldn't be too low, shouldn't be too high, and there shouldn't be any gas and liquid interactions. Yes, the gas should not undergo compound formation or dissolution or dissociation. And also air. Now the question has come. H2S is a toxic gas with rotten eggs-like smell. It is used for the quantitative analysis of the solubility of H2S in the water. STP is 0.195 mole kg inverse. Then the Henry's law constant is. Bacho, here I want to tell you very important thing. For NEET examination, you are going to get direct NCERT questions. You can expect 50% of the questions. And NCERT textbook and NCERT textbook, you have in text question, example question and everything, and NCERT exemplar. If you take this NCERT textbook and NCERT exemplar, you are going to get 60% of the paper, 60% of the paper. Rest of the 20% is going to be the stock questions like the other PYQs. And the competition and game winning breakthrough will be observed only at the last 20%. So, आपका जो talent है, आपका जो मेहनत करने हैं, that 20% का आसपास में decide करते हैं. This is fact. Okay. So, in order to play a safe game, 60 to 65% और इससे ज़्यादा भी आ सकते. Copy and paste 60% of the paper from the copy and paste from NCERT textbook as well as NCERT exemplar. Agree with that? Agree with that? You want me to prove the questions also? I am ready to prove that. Anushka Roy, you want to say it is? Answer 3, 462. How it is? How it is 462? Open your NCERT and the same question is there in the NCERT. Same question is there in the NCERT. You can see it is going to be 285 is coming. It is going to be 285.6 is coming. और एक बार करने का कोशिश करो जल्दी जल्दी जल्दी. Or you want me to do Anushka and Suchiprata? So, the answer comes to be here. KH is called Henry's law constant, X is mole fraction at STP, it is given pressure is 1 atm. Why it is given at STP? Okay. As this is given at STP, pressure, external pressure is taken as 1 atm. Now, 0.195 molar means 0.0195 mole per kg gas dissolved per kg. Per kg means 1000 grams. 1000 grams means 55.55 moles. Okay, this comes as 55.55. Understand? Mole fraction of H2S is NH2S upon NH2S plus NH2, number of moles. So, mole fraction of H2S is 0.195 upon 0.195 plus 1000 by 18. Okay, so it comes to be 0.0035, that is the mole fraction. From this, P is equal to KH into mole fraction. So, KH is equal to STP 1 atm, okay, and upon 0.0035, it comes to be 285.7. Okay, Louis NS Sir, I am Suresh, faculty of chemistry, beta. Okay. Any doubt? This is directly asked from the NCERT and you can have the NEET examination. I could find out 4 or 5 questions are directly extracted from the NCERT questionnaire itself. So take care of your questions. Each and every line from the NCERT is completed from the NCERT Express in the month of September, October, November. Remember? And once NCERT is completed, we are into the questions now. One more question, up kar le. Anushka Roy, here it is. Which of the following gas greatly deviate from Henry's law in the water? Greatly deviate. Why greatly deviate? Why greatly deviate? Please tell me. The Henry's law is applicable whenever gas do not react with the solvent. Bishal Mukherjee, H2 do not react with water. N2 do not react with water. CH4 do not react with water. Where NH3 is going to react with water. Whenever the gas react with water, na kya hoga? It is going to give rise. Do not follow Henry's law. Mean to say it deviation. It deviates. So NH3 is the answer for this. Everybody is given the correct answer for this question. That's good. Bacho, Aurek? Yes, it is going to be answer 3. And one more. Low concentration of oxygen in the blood and tissues in the people living at high altitude is due to. Direct, this question is also given from the NCERT. These lines are taken from the NCERT. Boys, read the question. Low temperature, low atmospheric pressure, high atmospheric pressure, both low temperature and high atmospheric pressure. What could be the answer for this? Everybody look at this, look at these options. One option is going to tempt with another option. You want to say low atmospheric pressure. Bishal Mukherjee, Anushka Roy, iska answer kya hoga beti? Now this is the case where I just want to give only it is related to the low atmospheric pressure. Never claim that low temperature. What's the guarantee that high altitude you are going to have a low temperature? It all depends upon its tertiary, right? Yeah, it is going to be 2. That's very good. And the next question. Before going for the next question, Bacho, here again a promotion slide aa chuka. NEET 2025 All India Test Series Pack. And this test series pack is utmost advised to the students preparing for the NEET examination. Why? Because आप जितना भी पढ़ाई करो, आपका क्वेश्चंस आंसर करने का वक्त में कुछ दिक्कत आ रहा है. Okay, so to overcome that universal problem, you require this AITS examination. I strongly suggest that. So this cost is 5,999. When you apply YouTube 50 off, you are going to get 2,999. That's very, very, very simple. Okay, and it is so cheap and you can start it. Right, so let's see one more. Here it is about vapor pressure. What is this vapor pressure? So little concept about the vapor pressure. Again we'll go into the questions based on the vapor pressure. Everybody get ready that. So the liquid is going to be evaporated like this. When it is closed, the liquid is going to hit back on the surface of this liquid and they'll condense back, and there is an equilibrium between the evaporation and condensation. This is called state of equilibrium. At the state of equilibrium, the pressure exerted by the vapors on its own liquid is called equilibrium vapor pressure or simply vapor pressure. Understand? That's very, very important, the definition itself. And the pressure exerted by the vapor molecule on its own liquid. Okay, Anushka, right? When they are at equilibrium, it should be at equilibrium, right? And here, vapor pressure of the liquid depends upon the following factors. One is the nature of liquid, another one is the temperature. So vapor pressure, I just want to give you very important point. Vapor pressure is inversely proportional to intermolecular force. What are the intermolecular force? IAEA van der Waals forces, dipole-dipole forces, ion dipole forces, London dispersion forces, hydrogen bonding, many things are there, induced dipole forces. And as the intermolecular forces increases, the molecules are tightly bound in the liquid itself. Evaporation process decreases, vapor pressure decreases. And one more important point here, it is temperature. Vapor pressure is directly proportional to absolute temperature, क्योंकि kinetic energy is directly proportional to temperature. So these are the two major points we need to know. Okay. Now let's see the details about all these things, volatile and non-volatile, and those liquids which has the tendency to evaporate are called volatile liquids. The liquids which do not have a tendency to evaporate is said to be non-volatile liquids. Okay. And you see, vapor pressure increases exponentially with temperature with different ether, alcohol, benzene, water and octane. So as intermolecular forces increases, molecular weight increases, vapor pressure decreases. And these are related to the ln P, vapor pressure, log vapor pressure is equal to minus enthalpy of evaporation upon R into 1 by T plus constant. Okay, so that we'll discuss. Yes. So if you draw a graph between log P and 1 by T, you are going to get a slope. Slope is going to be minus enthalpy of evaporation upon R. Okay. Now we'll see boiling point, the temperature at which the vapor pressure is equal to atmospheric pressure. External pressure, then the liquid start boiling, that is called boiling point temperature. So as the liquid with vapor pressure, high vapor pressure will have the low boiling point. That is also a very important point. So this vapor pressure is connected to all colligative properties, my dear students. So don't worry, I am going to come up with some questions based on that. Vapor pressure of a liquid solution. 2 minutes you give, 4 or 5 slides are there, again we are going to discuss about the questions, right? So stay tuned. So Raoult law, what is Raoult law? What is Raoult law? Raoult law means partial vapor pressure of A is directly proportional to its mole fraction in its solution, right? So I mean to say partial vapor pressure of A is equal to its vapor pressure in the pure state and its mole fraction. This is what is called as a Raoult law. According to Raoult law, I want to say here Pa is equal to P naught A mole fraction of A, Pb is equal to P naught B mole fraction of B, right? And P total is equal to, if it is say, so Pb is equal to, is directly proportional to mole fraction of B, Pb is equal to P naught B mole fraction of B. So when A and B are mixed, Pt is equal to, my dear students, Pt is equal to Pa plus Pb. So you can say P total means total solution vapor pressure is equal to P naught A mole fraction of A plus P naught B mole fraction of B. Okay? Right? So that's I want to explain you here. P total is equal to Pa plus Pb, that is equal to P total is equal to Pa plus Pb is mole fraction of A, P naught A plus mole fraction of B, P naught B, or you can also say P total is equal to 1 plus mole fraction of B, P naught A plus mole fraction of B, P naught A, because mole fraction of A plus mole fraction of B is equal to 1. Is equal to 1. Hey, Kina? That's good. Now you are going to see On the other ways, you are going to see for a solution, if you want to say PA and a mole fraction of A, it is going to be a straight line passes through the origin, right? And when you talk about here PB and a mole fraction of B, it is going to be like this, a straight line, it is going to be a straight line like this. It is going to be a straight line like this, and this is going to be P total. Yeah, it is going to be P total is equal to PA plus PB, and it is going to be PA is equal to P naught A mole fraction of A. It is going to be PB is equal to P naught B mole fraction of B. I just want to say here, any solution which follow this graph. Nando, hi, you are not there in the previous couple of classes. Any solution which follow this graph and this expression is said to be an ideal solution. So we are going to focus on the ideal solutions. Anything is deviating from here, it is called positive deviation or negative deviation. For an ideal solution, intermolecular forces between A and B should be, magnitude of the intermolecular forces should be same. Fine? So this is very, very important thing you need to know. Fine. You are late. Why? Nandu, why so? Okay, are you attending the recordings also? Because a very good questions has been discussed in the previous classes, no? You missed it. Now let's talk about, this is about an ideal solution, and let's talk about this is very important. When this is a liquid and here you have mole fraction of A and a mole fraction of B, and in the vapor state you have mole fraction of A and a mole fraction of B. Very good. So whenever you talk about XA and XB, they are the mole fractions of the component A and B in the liquid state, while in the Ya and Yb, they are the mole fractions of the components in the vapor phase. So to calculate the mole fraction of the component in the vapor phase, NEET examination में बहुत काम आ जाएगा. Pa is equal to Ya P total. So mole fraction of A in the vapor phase is equal to Pa upon Pt, or you can say Ya is equal to P naught A mole fraction of A upon P naught A mole fraction of A plus P naught B mole fraction of B. This is a super awesome. And again you have Ya plus Yb is always supposed to be 1 for the fundamental aspect is concerned. Agree? And we'll do some questions based on that. Come on. You all copy these formulas. You all copy these formulas. Ideal and non-ideal. So the solution which obeys Raoult law in all conditions are called ideal solutions. All concentrations is the ideal solution should obey Raoult law. For that, enthalpy of V mixing is 0 and change in the volume is 0. Intermolecular forces magnitude before mixing and after mixing is same. And you have various examples for ideal solutions like benzene and toluene, N-hexane, N-heptane, ethyl bromide, ethyl chloride, chlorobenzene and bromobenzene. So these are all ideal solutions beta. These are all ideal solutions, right? Nandu, agar kuch doubt hai na to puchna. and you can say non-ideal solution where you don't see the solution is observing the ideal rule, that is Raoult law at all concentrations. Okay, so this could be a positive deviation, and positive deviation, it is supposed to be like this, the solution, but the vapor pressure is more than this, is called an vapor pressure, the solution badte rehte, so it is called as a positive deviation. So the key point is intermolecular force of the solution is less. I mean to say, the A and B may be having some more stronger hydrogen bonding or so is disrupted during the solution formation, and for that you need to have acetone and carbon disulfide, acetone in ethyl alcohol, acetone and benzene, methyl alcohol in the water. So hydrogen bonding is destroyed, you can see oxygen and hydrogen is having hydrogen bonding. When you add methyl alcohol, methyl is going to be an alkyl group. So this methyl group is going to disrupt hydrophobic interaction ka wajah se the intermolecular forces are destroyed. This is the key point. This is the key point in understanding the positive deviation. Hi Madhavi. Hi Madhavi, right, come on, right. So now let's talk about the negative deviation and we'll start the questions. Ready for that? And you have so many examples, and talking about the negative deviation, for showing negative deviation, it is supposed to be like this. It is supposed to be like this. Vapor pressure of the solution is decreased. So intermolecular force of the solution increased. How, why it is increased? You can say chloroform in ethyl alcohol, acetone and chloroform. Excuse me. High electronegativity. Because of that, you are going to establish intermolecular force. That's the reason why negative deviation is shown. Okay? No. You want IP session, is it possible? Okay, IP session queue. Why IP session is required? IP session, half of the session you can extract it as an IP. You don't have to worry about that. Okay, here you can see these are the various examples. Enthalpy of mixing is negative, and volume of mixing is negative, and vapor pressure is decreased. Negative deviation, vapor pressure decreases. Positive deviation, vapor pressure increases. That's very important. And these are all the various examples. Talking about azeotropes, in the NEET examination, these azeotropes are very important. So azeotropic mixture, the component is actually deleted. It was deleted from the NCERT, but you learn a little bit less about the azeotrope. Azeotropic mixture are non-ideal solutions. Basically, they are non-ideal solutions, Nandu. They have the same composition both in liquid phase as well as in the vapor phase. Therefore, they boil together. So at certain composition, they have boiling, constant boiling mixtures. So the phase so they have two types: minimum boiling azeotrope and maximum boiling azeotrope. How do you know the minimum boiling azeotrope and maximum boiling azeotrope? The solution which shows positive deviation from Raoult law. and the solution which shows negative deviation from Raoult law. This is a simple trick that can help you to identify which azeotrope is it. Fine, that's very, very important. And moving ahead, some questions based on that I just want to discuss. Let's go ahead. Yeah, questions. Yeah. The vapor pressure of two liquids P and Q are 80 and 60 torr respectively. The total vapor pressure by mixing 3 moles of P So what could be your answer? Tell me. Students, it's your question. The vapor pressure of two liquids P and Q are 80 torr and 60 torr respectively. 1 torr is equal to 1 millimeter mercury, mind it. 760 millimeter mercury is equal to 1 atm. Of course, this is not required for this question. Don't worry. Vishal Mukherjee, you want to say D? No, Vishal Mukherjee always comes whenever the question comes in the chat box. Very good, Vishal. Nandu, Anushka Roy. So, Vishal always talks to me when question comes. Right. Here it is correct. It is answer 4 is correct. You said it is D or 4 doesn't matter. You can see, bacho, let X and Y be the mole fractions of P and Q. And you can say P solution, P naught and mole fraction of this and P naught, okay, P naught P and P here, yeah, and P naught Q and YQ, right. Now that is given as 80 into 3 by 5, 60 into 2 by 5. On solving you are going to get it is 72 torr. Any doubt? Any doubt? One more question for you, students, one more question here. Now, the system that forms a maximum boiling azeotrope. Maximum boiling azeotrope means negative deviation from Raoult law. Negative deviation from Raoult law. You want to say D or C? Nandu? जल्दी बताओ विशाल. कार्बन डाइसल्फाइड and acetone. It is going to be, yeah, acetone and chloroform. Negative deviation. Vishal Mukherjee, you can say acetone CH3, C double bond O and CH3 and chloroform C, Cl and Cl. So when you talk about between these two, hydrogen bonding is formed. When hydrogen bonding is formed, I would say intermolecular forces increases, vapor pressure decreases. So the vapor pressure decreases, negative deviation from Raoult law. Whenever negative deviation from Raoult law, maximum boiling azeotrope will come. Vishal Mukherjee, Nandu, and I was saying the same thing. Don't focus on solving a lengthy numericals and tough numericals. See the logic. You can use the logic, you do the best. Agree? Fine. Now one more. A solution contains hydrocarbon A and B in the ratio of 2:3. And the vapor pressure of the pure hydrocarbon at 25 degrees centigrade, 300 and 100 mmHg respectively. The mole fraction of B in the vapor phase is talking about vapor phase. Why you have to calculate? Why you have to calculate? Remember, Calculate Y, apply the formula, take a minute. Take a minute. Okay, Vishal, Nandu, Madhvi. Yes, it is. Look at this, how to solve this. You know, mole fraction in the vapor phase is equal to YB is equal to P naught B mole fraction of B upon P naught A mole fraction of A plus P naught B mole fraction of B. And we have the ratios 2:3, 2 by 2 plus 3, 3 by 3 plus 5, right? So 2 by 5, 3 by 5. So put that 100 into 3 by 5 upon 300 into 2 by 5 plus 100 into 3 by 5. I just want to say 1 by 3 is the answer. Anything? Yes, it is 3 is the correct answer for this question. Super. Now one more question, the vapor pressure of pure benzene and toluene are 160 and 60 torr respectively. The mole fraction of the toluene in vapor phase in contact with equimolar solution. Equimolar solution mean to say number of moles of benzene and number of moles of toluene are same. Okay, and is. You tell me answer. Fatafat, jaldi. Make it fast, make it fast. Okay, so Vishal, you kept quiet. Nandu, Madhavi, Anushka, fine. That can be given as 0.27. How it is for equimolar solution? Mole fraction of A is equal to mole fraction of B, okay, is equal to 1 by 2, because this plus this is equal to 1 only, no? So partial pressure of benzene is equal to 160 into 0.5, 80 torr, and partial pressure of toluene is equal to 60 into 0.5 is 30 torr. So P total is equal to 80 plus 30 is equal to 11 torr. So you got the P total. Now you have say mole fraction of the toluene in the vapor phase is written as partial pressure of toluene upon total pressure, that is 30 by 112, 110 is equal to 0.27 is the answer for this question. Okay, clear? Perfect, students. Wonderful. Vishal has given the correct answers. What about other students? Just watching, and I am expecting you to give the numbers. Charting should be live. Charting should be live. One more question. The vapor pressure of pure liquid A is 70 torr at 27 degrees centigrade, and it forms an ideal solution with another liquid B. The mole fraction of B is 0.2, and the total vapor pressure of the solution is 84 torr at the same temperature. Okay, and you are asked to calculate the vapor pressure of the pure liquid B at the same temperature. Again, options are for you. Options are for you. What could be the option for this question? Expecting an answer? Will you solve or you want me to solve? I think you can solve it. I'll wait for your answer. I'll wait for your answer. Vishal? Okay, I'll wait. So this is a live interactive session where teacher is giving questions and explaining the answers, and the students are also giving the answers. If you give answer, if you have any doubt, you can ask and you can share your opinion as well. So feel it is a very interactive session. You want to do the same transaction, you just have to go to join in a coaching institute, have to pay huge amount of money, and on the YouTube platform the same senior faculty is coming and giving such a facility full free of cost. So please get an advantage of this. Vishal, again you want to say C. Okay, why should I deny it is a C? So the answer comes to be yes, it is 140, coming to be according to Raoult law. P total is equal to P naught A mole fraction of A plus P naught B mole fraction of B. Here, if you take P naught A 70, mole fraction of A is 1 minus mole fraction of B. It is given as a 0.2 now, so you subtract from this going to be 0.8, and P is given 84, and plugging this is going to be 84 minus 56 upon 0.2 comes to be 140 is the answer for this question, right? This is a simple question, you can solve it, and you are going to get same model of questions for the NEET examination. Undoubtedly, some previous year questions are also included in this session, mind it. Okay, beta? And the vapor pressure of water at room temperature is 23.8. and the vapor pressure and aqueous solution of sucrose with mole fraction is 0.1 is equal to. Solve it. You want me to solve? Will you solve? It all up to you. You want me to solve? I'll solve it. Okay, come on, Vishal. So this could be the last question of the day. I am going to send you a very good wishes to you personally. Okay. So all the best. Do this question. I'll wait. What is your answer here? Vishal Mukherjee and Nandu and Madhavi, Anushka Roy. Now this question comes as answer is C. So 21.42. How it comes to be? Look at this. Vapor pressure, lowering of vapor pressure is equal to P naught and mole fraction of B. How it is? Delta P by P naught. This is relative lowering of vapor pressure is equal to mole fraction of the solute. And delta P is equal to P naught mole fraction of the solute. That's what it is given here. And it is P naught is 23.8 and mole fraction is given 0.1 is 2.38. Okay. So it is vapor pressure of the solution. इसमें subtract करने के बाद मिले 21 plus 42 आएगा, है क्या ना? Got it? Answer? Any doubt in this question? Students, we had a very good swell about the vapor pressure, solubility, Henry's law, vapor pressure, Raoult's law, and these four concepts we completed along with the multiple choice questions. And all students follow our lectures, and which completes complete concept as well as the multiple choice questions which are more expected towards the NEET examination. So every day my session is going to be 1:30 p.m. Stay tuned at that time along with your pen and book and solve along with us. Okay. So tomorrow again we'll talk about solutions and colligative properties part 3 with colligative properties questions along with 1.5 factor. Everybody stay tuned. So signing off, Suresh, Faculty of Chemistry. Thank you. Please like and share and subscribe this Infinity Learn NEET YouTube channel. Thank you very much. 1 minute.